Well, let's kick off today's summit. Today's Mobile Quality Summit is brought to you by Sauce Labs, Curiosity Software, and TestRail. We believe that this combination of tools and this combination of partnerships is going to be the complete solution that everyone needs in order to be able to create and implement the ultimate test strategy. And so we're going to start with a little bit of a conversation around risk-based test generation for mobile. And then we're going to talk about orchestrating testing efforts for enterprise success with TestRail. So first hour will be Curiosity, second hour will be TestRail. I'll be here kind of throughout, sort of chiming in from here time to time. And then my colleague Nikolai Abelodkin will join us also to help MC the next hour. But first, let's kick off the conversation about Curiosity. James, why don't you introduce yourself?
Yeah, thanks so much, Marcus. Really excited to be part of this session today. So my name's James Walker. I'm one of the co-founders of Curiosity Software. I guess my background is I've spent kind of the past decade in the automation space, specifically in an area which is called model-based testing, which is what we're going to be talking about today. And really, we've been trying to apply kind of new techniques, new technologies, new approaches for software quality. And one of the big reasons for that, and what we're going to be talking about today primarily, is looking at risk-based testing. And specifically, we're going to look at that for mobile. So very excited to be here with Marcus. And yeah, looking forward to sharing our journey, I guess.
Great. And my name is Marcus Merrill. I'm the Vice President of Technology Strategy here at Sauce Labs. I come here after about a 21-year career in quality assurance, test automation architecture, and test scalability, basically. And I'm here today to talk about how James and I think this is probably our fourth co-presentation now, where we basically talk about how a lot of teams tend to test a little bit too much. They tend to over-rely on certain areas of tests that turn out not to be terribly important. They don't base their testing strategy on things like risk. They base it on things like test coverage. So with that, I'm going to get straight into what we want to talk about today, which is I want to start with a story. Basically, I was working for a company for a long time, and we had kind of a shockingly good track record at producing software that didn't really have earth-shattering defects in production. We weren't perfect. Nobody's perfect. We were good. We never had an outage at the most critical time. It was an e-commerce platform. We never had an outage during like Black Friday, Cyber Monday, the really important Mother's Day, Valentine's Day. We never had outages during those critical times. When we shipped a bug to production, it tended to have a fairly small blast radius. And it tended to be something that we could roll back fairly easily. I mean, things happen, but usually they didn't happen at the worst time possible. And I think it's, honestly, I would say it's because we took the risk-based approach that we'll be spending the next hour talking about. Now, it's interesting because toward the end of my tenure there, we got a new CTO. And he had come from a much larger company, much more bigger name company. So it felt like he came in and he was going to save us all. And he basically told me, first off, he said, Marcus, I want you to prove to me that your automated testing is covering 100% of the code that we write. And I was kind of taken aback because I felt like this conversation had died out in the early aughts of QA, but evidently it hadn't. And so he said, give me 100% test coverage. And I was like, but we do a good job here. You know, it can always be better. We can always show improvement, but I didn't feel like it was an appropriate request, to be perfectly honest. So what I basically said was, I will deliver 100% code coverage if I get to decide what 100% means. Does it mean 100% of business logic, 100% of the kinds of error side cases and edge cases that are really, really hard to trigger? Does it mean 100% of all microservices and every single team that we're interacting with that is feeding, that we have a dependency on? Does it include 100% of all API contracts for third parties that we use? Does it include configuration? Does that include that we're testing all configuration that we have in our cloud infrastructure and every permutation of different kinds of ways we can deploy this application? Because as we implemented DevOps and SRE principles, config became code. Is that part of the 100%? And it was shocking to me that this was what had occurred to me is that essentially, and I don't necessarily expect you to read this slide, we will leave this slide behind, but what it felt like was that we had a new CTO who was trying to earn their bones real early on by essentially getting a trophy saying, hey, we hit 100%. Look what I did. Look what I did for the company. We hit 100%. And it failed to take into account at all this concept that, maybe you don't really need to test it. Maybe if you test this over here, you're losing out on the opportunity to test this over here. Because already once during this career path, I had run up into a situation where I went all in on covering this very small user profile piece that someone told me later is like, yeah, I'm glad you wrote 100 test cases around that, but do you understand that less than 1% of our users ever use that code, and it produces zero revenue for the company whatsoever? You should be focusing your efforts on the areas of the product that generate revenue. And that's what we did. We identified the biggest risks in the product. We made sure that we were covering those in our test cases, automated test cases. And then we focused solely on getting those to be very, very deep, as opposed to mile wide and deep. We went deep on the areas of risk focus and not so much on the areas that, if someone's editing a user profile, it's going to be moderately important. 3 test cases can cover that, not 100, that kind of thing. So what we're trying to do in this conversation is make sure that we're helping you manage risk and communicate risk to your executive level. Because I have a longstanding theory that that the way QA and testers and developers who are working in test become relevant and become critical to their organization, become strategic to the organization, is by talking about risk. Risk is first. Then you talk about cost management, capital allocation, and efficiency. Then we talk about maximal customer experience, which is also context dependent. You're much more concerned about customer experience if you're working on something like a game or an e-commerce platform than you are talking about something like where the user's essentially locked in. Like if it's a mortgage company, then someone's using your company, they probably can't switch from yours to another. So customer experience isn't critical. The user paths around making sure that money gets transferred and they can set up ACH withdrawals, that kind of thing is critical. So then how do you get to optimal developer and QA productivity and create the best developer and QA experience? These are the big 6 challenges that we talk about all the time in the software development lifecycle. And I believe that leading with risk and not ignoring coverage, but using coverage as a step toward telling you something about your gaps. Coverage is there to tell you what you're missing. It's not there to tell you whether or not your software is quality. And I would challenge everyone in the audience to challenge anyone who tells you that coverage is the goal with this nugget that coverage is a very good metric to tell you what you've missed. It is not a very good metric. It is not at all a proxy towards quality. So you base everything with your test infrastructure, applications, intelligence, analytics, test strategy, and then you ship better code faster when you layer these things all on top of each other. And stepping back a little bit to parlay the concept of risk into the concept of test strategy, it's important to understand that when we meet people, in my career, many times I would walk into a new company and I would essentially, we would try to gather the lay of the land. We try to figure out what's going on. And I'm guilty of this, what I'm about to say is we would walk in and I would say, well, I'm a Selenium expert. Let's use Selenium. Before I even understand whether or not I'm working on a web application, you understand? Like I tended, and I since moderated this stance and I'm able to sort of fix this, but I see it all the time. People use the tools that they understand to solve problems that those tools may not have been built for. They choose the tools before they choose the strategy. And if you choose the tool before you choose the strategy, then you're aimless. You have no idea where you're pointing. You don't know where you're going to end up. You probably will spend a whole lot of effort working on the wrong problem. However, you do need to have good tooling after you set the strategy, because without executing the correct tooling, then your strategy was pointless to begin with. So everything is about risk. Everything is about strategy. Then things are becoming things become about tools. And that's what we're about to hand off in a couple of slides back to James to talk about how to use the model of your application to tell you what is the most important thing, what is the most high priority thing for your user. I'm asked all the time by our customers, what are the trends you're seeing? What do people want? VR, people want AI, people want to be able to test in a headless way, or people want to be able to test on this obscure device or that kind of a thing. And I agree, all those things are important. AI is taking over the world. Generative AI is going to become extremely useful as a tool for us in test automation. But AI, generative AI, is not a strategy. What I see as a trend is struggle, difficulty, failure to get quality signals out of the unbelievable amounts of test effort we put into our software. And that's what we're here to try to fix. We see struggle over tools, over the concepts of automation and the implementation of automation, because it's harder and harder as the years go on to find people who are really skilled at code who also want to stay in quality. Struggle over what is the expectation even? Do people expect me to automate 100% of code coverage? Do people expect me to deliver perfect software with zero defects, or are we mitigating things? We struggle over complexity constantly. We struggle over finding the people with the right skill sets. And when they have the right skill sets, do they have the right mindset? We struggle over when something escapes to production, how big is the problem? Is there a blast radius? Is it causing cascading failures elsewhere? And we struggle over whether or not we as testers can continue to remain relevant in the new world of DevOps and SRE, or are we becoming more and more relegated? Because I got to be honest, what we're seeing all over right now is that QA is the first to go in a layoff. And it's awful. It's because we are not recognized as critical to the platform. We are not recognized as strategic. And that is what we want to try to make, is quality as a strategy and as a strategic pinnacle of your software development cycle. I'm sorry, well, slide issues. Struggle I'm seeing in the industry every day when we talk to customers. It's not about the user. We don't struggle over what the user is accomplishing or whether or not the user is able to be successful on our platform. It's always about how many test cases do we have? How fast can we run them? How much coverage do we have? We're trying to earn trophies and we're trying to gamify the concept of testing, usually without much regard to the user itself, themselves. And that's something that we are aiming to change. I want everyone here to try to gain a seat at the table and to defend against irrelevance. The best way is to talk about risk. Quality is not about the absence of defects. It's about understanding that for your users, every experience in your software matters. Can they get done what they need to get done? They're not here to use your software most of the time. They're here to get a task accomplished. And understanding that is the easiest way to learn how to put quality into your product in a way that your executives will actually pay attention to. If you can catch the defect that prevented the $1 million bug, your CEO will understand the value of quality. So with that, I think I want to hand it over back to James to talk about how to put this into real context and apply risk concepts to an overall model for test success. Sound good, James?
Yeah, that's awesome. Thanks, Marcus. Let me take over the screen sharing. Hopefully that's this one. And let me push this one up. So I think just listening to you there, Marcus, I think the interesting thing is, you mentioned quality a lot there, and you kind of veered away from talking about testing too much. And I think, to me, testing is the process, right? It's like, it's how we get from, having something that's going to be released to checking it actually works. Whereas quality is more kind of this reason-oriented approach, right? We're trying to give people confidence in what they're delivering, and we're trying to move away from this kind of tick box exercise into creating really high quality software that goes out, right? And I think just from my experience, looking at the best organizations we've worked with, and I strongly believe quality is actually, it's strongly it strongly correlates to stock price and the success of a business. If you see an organization with poor quality, they're probably churning customers, right? If you see an organization with poor quality, potentially they're making bad business decisions because their back-end software is not operating and not giving the right decisions or the right information that they're basing their business decisions off of, right? So I think moving more away from this testing kind of narrative or talking about testing and moving more into the reason why we test, which is quality and delivering quality software, is super important, right? I think as an industry, we have to move more into that kind of segment. So with that in mind, what I want to talk about is moving kind of into modeling. And I'm going to talk specifically about some of the successes we've seen in organizations and some of the bad things as well. And really what I want to do is just add some color for how modeling can be applied to some of the challenges which Marcus was talking about there. So I think firstly, if you look back historically, and I agree with Marcus, code coverage has been a metric which people have cared about for way too long, and it's kind of past its expiry date, in my opinion. It's obviously useful for getting an indication and getting kind of a baseline number, but basing your whole test strategy on code coverage is crazy, right? And I think back in the days where it was, more kind of oriented around these kind of console-based applications, or you were talking more specifically about functions and procedures, maybe that did make sense. But if you think about, all the combinations of everything that's going on around us now, there's just so much out there, right? IT has just got more and more complicated. And I think every year that passes, it's just getting bigger and bigger, and there's just so much more stuff out there, right? And I think a lot of this kind of comes down to this move to openness that we've seen. We live in the world of the API where any software can connect to any other piece of software. There's all these SDKs out there that anyone can go in and start to extend an application. And basically what this means is almost everything out there is consumable in some shape or form. Almost every piece of software out there is extendable. And we also end up with these very open platforms. Like if you look at Android, where you can have thousands of different Android platforms out there, all running the same OS, but you've got different hardware sat behind it, right? So this is just more kind of a map, just to map out all of these different combinations. These are just picking out a few that we've seen in kind of the mobile space, and just to kind of highlight that explosion of all the complexities that are out there. If you look at a typical application, there could be thousands of different scenarios a user can kind of work their way through that particular system, right? There's so many different devices out there running these different operating systems. And there's probably a number out there that we didn't even know about. And occasionally a user will come along, they'll pick up a new device, and all of a sudden, we have something registered that we've never seen before. If you look at browsers, there's literally hundreds of them out there with different combinations. And then you've got the whole, explosion there of different browsers running on different operating systems on different devices. There's so many ways we can interact with different devices now. If you add that on top of localization, we've got different parts of the world. We've got Asia, we've got Europe, we've got the US, etc. There's so many different places where people can run these devices. There's different ways they can connect over the network. There's lots of different interruptions that can happen. And there's also many, many, many different ways we can deploy our apps so they can be pulled down and consumed by, our eventual end users, right? So I think, if you think about what Marcus is saying there, his experience where he went into this job for the first time, and, the C-suite or whoever that was went to him and said, we expect to have 100% code coverage. We want everything to be tested. If you think about this level of combinations here and this level of parameters that you're dealing with in this day and age, that's just impossible, right? We have to accept that getting 100% code coverage, testing every single possible combination is impossible. And I think, even from our experience, we still hear this a lot, right? There's a specific KPI that people are trying to hit. They're trying to go out and have 100% code coverage, or there's some kind of magic number of test cases that needs to be created that they're going to base their testing strategy on. Like we want 5,000 test cases to test this particular part of the application. And if you strip it back, it's actually, what's the purpose of this number? Why have we come up with that? And what's the reason for this? And usually there's not, right? So I think, if we go back to what I was talking about at the beginning, what is the reason we test? Well, actually, it's all about providing confidence to our stakeholders, to everyone involved in this project, that we have reached a certain level of confidence, that we're happy with what we have. We may not have tested everything, but we've tested the important parts of the application. And we have presented that in a way that we're providing confidence to everyone that we should be releasing our software, that we're in a good state and we're happy to move forward. So, just to kind of distill what we're talking about here, just take one slice, one instance, 472 different devices, 700 browser combinations, 7 locations, blah, 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 blah. You end up with a very big number very quickly, right? And, if I end up with a big number where there's potentially 30, 40, 50 million different ways I can test this, I have to be more intelligent about how I pick my test cases. I need to be more concise over where I'm going to focus my testing efforts. To Marcus's point, if this is a super important bit of my business, this bit of software, this particular feature, 90% of my users use it, I should be testing that more extensively. If there's a part of the application where if there's a bug introduced or we make a miscalculation, all of a sudden we're sending a lot of money to someone who shouldn't be receiving that money, then potentially that's another area of the business, another area of testing we really want to focus our efforts on, rather than something that is just out there, it's not used, or it has a very low impact on the business if that particular part of the application fails. So I think having this mindset and being aware that we're, testing everything is impossible is good. I think, having this mindset where we're going to focus more on quality, providing confidence in what we're building is even better. And I think taking this step back and taking that mindset where we're going to try and introduce quality everywhere throughout the whole software development lifecycle is absolutely crucial. I think if you look at an organization, one of probably the most problematic things that can happen is there is a business need. That business need gets formulated into some kind of user story or some kind of requirement. And then all of a sudden the wrong thing ends up getting built. And as part of that, we've ended up with something that doesn't meet the initial requirements and it doesn't work as expected. Okay, so introducing quality much, much earlier. If we can introduce quality as a requirement is being formulated, we can do much more upfront work. We can have our test cases automatically generated. We can have everything from that produced. That's going to put us in a much better footing as we move forward, delivering a particular user story or a particular part of that application. Now, a lot of people will talk about automation as kind of this, this silver bullet, right? Where we're going to introduce automation into the project, and that's going to make sure that we're testing effectively. And because we have automation, we're doing a good job, right? To me, if you think about automation, you think about manual testing, all they are providing is a vehicle to provide confidence to stakeholders that the software is operational, right? And maybe now that we have generative AI and these new kind of techniques formulating, that's just an extension of providing that confidence, right? Whatever path is chosen, whatever technology we choose, which we're going to be using to, basically assure people that we have a good product and what we're delivering meets those initial requirements. It's just a vehicle to providing that confidence, right? So if you think about manual testing, testing is often, the tricky bit because there's not enough time there, right? We don't have enough time every time that we're releasing to go away and execute these 3 or 4 or 5,000 manual test cases we have. So most organizations will take a standpoint, okay, we're going to move into the realm of automation. We're trying to release way more often. And as part of that, we need to run our test cases more often. And it's not feasible for us to have this manual test suite anymore, okay? So a lot of organizations will start to move into automation for that reason, okay? And that's pretty much the only reason I see for automation being there is to speed things up, do things with a lower level of bandwidth, and have this automated mechanism to saying, yes, our product is still working as it should. Now, for most organizations that we work with, I think it's very rare that you see an organization who has automation, who hasn't got themselves in some kind of pickle. You know, if you think about an automation framework, you think about an application, over time it gets bigger. You know, you have way more requirements, especially if the software is successful. You know, you're going to see customers making enhancement requests. Those are going to get built into the product. And very quickly, what you'll see is that as more features and more components get built, the automation framework and the amount of automation we have should grow along with that, okay? And without the right architecture there, this can get very, very messy incredibly quickly. So I think a core piece of automation is having the right architecture there and following the same kind of standards as you would for the automation framework, as you would for any other piece of code in that organization. You know, you've got code reviews, you've got architecture reviews, and you're constantly looking at evolving and applying new techniques to that automation framework. I think the other tricky bit with automation is the maintenance often becomes kind of the most time-consuming piece. And I think if you speak to a lot of people in the automation world, they will very quickly tell you that test automation or, you know, test maintenance can kill any return on investment we expected from test automation that we were applying, right? And I think firstly, you know, that's because there's not enough skilled engineers to keep up. It's also because of this architectural problem and technical debt in the automation framework that builds up over time. So what we're going to look at specifically is around modeling, okay? And what I would like is if you could go back, you could think about kind of this whole Three Amigos approach where everyone's trying to help with quality, everyone owns quality, and we're trying to remove silos so everyone can work together in implementing quality throughout an organization. Okay, so let me just skip forward a few slides. So model-based testing, I'm going to talk a little bit about the benefits firstly, and then we'll go into looking at a bit more of a hands-on example of what model-based testing is, how it can be applied, and also the application of that in kind of the mobile space. Okay. So model-based testing is an approach I've personally been working in for the past decade. And basically, the whole purpose of modeling is to create this kind of visualization, this visual image of this is exactly how a feature or a part of the application should work and how it should be built. And from that, we're going to use it to create our test suite. Okay. Now, one of the nice things about modeling is that by nature of creating a model, you're actually maximizing reuse. Okay, once you create a model, it becomes a reusable component, but also you're creating this visual image, this visual construction of the application using a flowchart, and that by nature has everything combined into one. So if you think about your usual testing that you will do or your usual test scenarios you create, it's essentially lots of lists of test steps, right? You've got step 1, step 2, step 3, then you've got another test case and you may have them all duplicated between them. Because we're talking about modeling, we're talking about a flowchart, you end up with everything merged together where you have a single source of truth and you have one place for one step in what's being created. I think the other core bit about modeling and model-based testing is you use it to auto-generate test cases. So you take this flowchart you've built and you offload the complexity of auto-generating the test assets into the computer. So you say, go away, generate for me the perfect test suite, which targets these particular coverage metrics and these particular coverage profiles, which are important to me. So coming back to that whole risk conversation we were talking about earlier, where there may only be certain parts of the application you want to focus on and you want to test, modeling is 100% built with that in mind, that you can say, go and explode on this area of the application, give me happy paths coming in and out of this particular component. I think another core piece is collaboration. You know, if you think about the requirements problem where the wrong thing got built and made its way into the application and it didn't meet the initial requirements where it should have, a lot of that is actually a collaboration problem. It's not having everyone on the same page about what should be built and how that particular component should operate, right? So modeling by itself is incredibly visual. It's all about collaboration. It's all about getting everyone on the same page. And a lot of that as well is actually offloading complexity, from our human cognition into the machine and letting it handle that for us. So we're going to jump more into a hands-on demo. This is basically just distilling what I'm going to show. And basically what we're going to do is we're going to go through kind of an end-to-end flow. We're going to look at a model specifically. We're going to look at one component of that model. We're going to look at some automation overlaid on the model. And then finally, we're going to go back to generating some tests, generating some automation. And we're actually going to see that executing within the Source Labs cloud environment, which is great for scaling out your automated tests on web and mobile. So let's move away from the slides. It's probably enough slideware. And we're going to move into looking specifically at modeling and model-based testing. So when I'm talking about a model, I think a lot of people can get scared very quickly. A model is really just a flow chart. It's really not complicated. You'll see here we've got a flow chart with several components linked together. Okay. Now this is actually for the Swagger Labs application. So for those of you familiar with Source Labs and your Source Labs environment, I believe this might be one of the first kind of tutorials you go through creating some automation for this application. So hopefully a few of you have seen this before. What we've done is we've built out a model for this kind of e-commerce app. And what you'll see here is at the beginning, we load a device. We're then going to go through a menu in the application. Based off of what we choose in the menu, we're going to go through our shopping catalog, where we can end up going through a shopping basket and we can end up checking out and buying some products, right? Or we may decide that we're going to go through a login flow. Now, what's special about this model is if I come in, I can start to explode these. And what you'll see is that actually what we have here is this kind of concept of componentization. These are actually sub-processes and they exist within their own right, okay? Now, the whole purpose of modeling is once you model something once, that's great. It goes into a reusable component library. And what you'll typically find for an organization is they will build up this library of common components for their application as they go through this modeling exercise. Now, the benefit there is you only model something once, okay? So it means you have a single source of truth. The second benefit is you have this reusable library. So when it comes to much larger end-to-end testing, which is what a lot of organizations are trying to do now, rather than just testing in kind of silos in their UI, is they just come in, they drag and drop these sub-processes together, and they can connect them all to create these much bigger end-to-end flows. The third benefit here is around test maintenance. If something changes in my catalog, all I have to do is go and open up this model. I can change the user journeys in here. I can add some new blocks. I can change the structure, hit save, and all of my tests are regenerated, and everything from that propagates downstream into my testing efforts. Okay. Now, what I want to do is just focus specifically on one of these sub-processes. So we're going to look at the login sub-process. Okay. And I've opened that up here. Now, if we look at the login, okay, what we're going to do is we're going to open the app. We're going to go to the page. We're going to enter some kind of email. We're going to enter some kind of password. And at the end, I either end up in an error condition or I end up clicking the sign in button and I end up successfully authenticating. Okay, that is literally what a model is. We have a starting point. We have states we can end up in. Everything in between is the logic and the different user journeys I can work my way through to end up in one of these conditions. Okay. Now, what's special about this model, if we take a look, we have some test data sat behind here. So for the email, we have different equivalence classes. I can end up with a valid email. So here we've got a valid email address. I can have an empty email. I can have email with no @ sign. I can have an invalid password. I can have a valid password. Actually, if you look behind this, what you'll see is there's a whole world of test data generation functions. Okay. And what that means is that we can start to move into the realm of synthetic data. So we can start here, we can go away and we can generate random first names that come back. So here you'll see we've got a few that are coming back here. We can also do expressions in here. So we can start to apply formulas. But the main benefit is we can start to overlay rich sets of test data as we need to into our models as we're creating them. The other piece that you're going to see here is that we have automation overlaid. So here we have a piece of automation which is going to go and enter an email. If I look at this particular function, this is actually going into a web page. We have an XPath sat behind this. And actually, if I go a bit deeper, what you'll see is that we have the Selenium and Appium automation code to go and automate that particular part of the application that we're testing. Okay. Now, the end result of one of these models that we have, what we can do is we can hit this generate button here. And what that will basically do is take the model we have, and it will go away and produce the optimal test suite to go and test that particular model. Okay. So, we're not thinking about code coverage here. We're thinking about the optimal way to test the model we have in front of us. And we're going to base our level of coverage more around the functional aspects of the application and around the user journeys so the user can work their way through the system. So we'll dive into coverage a little bit more on our bigger model. But here, what we've said is we want a medium level of coverage. And what that basically means is we're going to cover every single edge in the model, and we're going to produce the minimum number of paths to meet that coverage criteria we've given. And it just so happens here that that is actually 4 paths. So we have 4 test cases for the login screen. Okay. Now, this is an intelligent way of creating tests. We could say, go and give me every possible combination, give me every exhaustive route. But if we see, as we've seen in the slides, this number gets very big very quickly, right? So this is a way of being able to more intelligently specify where we want our test to focus on, and we can then produce the corresponding perfect test suite to test that particular risk profile or coverage profile we've given. Now, once I've got these paths, I can do something with them. So it may be that we want to go and populate a requirements management tool. We want to go and create some test data and push that into a test data management system or into an external database. We could go off here and we could say, let's create some test cases. And we could populate these test cases into a test case management tool like Jira or Azure DevOps or TestRail, who we're talking today. Now, if we open this up, I've actually just created a very simple Excel sheet here. Just for the sake of time, I'm not going to connect into a test case management tool. But what you'll see is that from this, we had 4 test cases. We've come out with our steps here. We've come out with our descriptions, and we've got some expected results as well. Okay, so this is how we can move from the model into the realm of populating the more traditional test case management type approach that we would typically see. Now, I'm going to come up to our bigger model here, okay, which is where we've got the full end-to-end of going through our e-commerce application. And what I've done here is I've set up a few coverage profiles. Okay, the first coverage profile is actually fairly simple. Okay, this is our default profile. Here we've got 22 different user journeys. And in this particular instance, we're just setting a medium level of coverage as well. So not terribly exciting. Now, let's start to think about areas where we want to focus our testing efforts. Okay, so here we've set up a coverage profile specifically for Android. Okay, so we've applied some tags on the model. And here we're saying we want to have a high level of coverage for Android, but for iPhone, we don't really care. We want to ignore all of our tests focusing on the iPhone platform. Okay, we've also set up another coverage profile here. And this coverage profile is focusing around the checkout screen. So here we're going to say for Android, we're going to get a low level of coverage. For iPhone, we want to focus a high level of coverage. And for our checkout system, this is actually super important for us. We've seen some recent changes go in, and we know that checkout functionality in particular has been impacted by that functionality. So we're going to give this an exhaustive level of coverage, and we really want to focus our testing efforts on this particular part of the application. Now, the great thing about modeling is once I've built that profile, literally all I have to do is come in, hit the generate button, and what that will do is it will produce the perfect set of test cases which revolve around that particular part of the application that I've selected to focus my testing on. Okay, and that's really what modeling is all about, building out this visual flow of the application, being able to specify exactly where I want to focus my testing efforts. And then once I've done that, I can use that model to go off and produce different assets. So the next asset I want to move into is automation, which I'm guessing a lot of the people on the call today are going to be caring about. Now, when it comes to automation, literally what we're doing is we're taking these 22 paths or scenarios, if you want to call them that. And we're going to produce the associated automation code for them. Okay. Now, there's nothing clever going on here. We're literally just producing the same automation code that an automation engineer would write. We're creating new page objects. We're calling the functions on those objects. And what we're getting from out the back end from that is basically 22 automation scripts, which represent these different pathways that we have here. Okay. Now, we have some automation, which has just gone up and is running. And I think if I log into my Source Labs account here, and we take a look, hopefully what we'll be able to see is some of that automation. Yeah, it's being queued up here. We'll see that we've got 5, which have just been queued up for execution. Now, I'm just going to pick out some of these, which I just ran before the webinar, just for time's sake, so we kind of fast forward a little bit. So here we've got one specific example that we executed from the model. And what you'll see is that this starts off, it opens up the Swagger Labs e-commerce store. I think in this example, we potentially go through and maybe order a backpack at some point. Maybe that's one of the bigger ones here. Let's see what we got. Yeah, here we go, where we go through the catalog. That's a bit more interesting. Let's open up this one. Yeah, we'll see there's a lot more activity here. So we start off, we go into the e-commerce system, we go through the menu structure. In this case, we're going to go through and order a t-shirt, and then we go through the login screen, and then we go through the checkout process at the end. Okay. All of this has been driven from a model that we have created, and all of the tests that have been populated in Source Labs have come through this test generation algorithm that we specified. Now, just to top everything off, what you'll also see is on top of these tests that we have here, we have the run results overlaid on top. So let's pick one of the bigger tests here. So this one has 63 steps in, so it's probably a little bit more interesting. If we look at the run results, what we'll see is that we've also got those overlaid on top here. Okay, so we're going through, we're clicking the backpack, we're ordering the backpack, and we're going through this checkout process and payment process at the end, right? So you've kind of got the full end-to-end workflow there. You can start with anything. You can start with a requirement, you build a model, you overlay your data, your automation, and then you can use that to drive your automated testing within Source Labs against your mobile environment. Now, the one I just want to finish up on is an area that we're doing quite a bit of work in at the moment. And that is looking at how we can use generative AI, specifically in the testing space. Okay. Now, what we produced is a little utility, which is called Model GPT. And what this basically allows you to do is to paste in your requirements. So if you've got a user story in Jira, absolutely perfect, you paste that in. Or it may be that you've got something out there that you want to describe, a problem statement, or a model you want to produce, and you can very easily distill that in a couple of bullet points or a paragraph. Here, I've actually just gone into Model GPT and said, I want you to create a model for ordering a taxi through the Uber app. Okay. And that's come back and it's created a version 1 of this for me. Okay. Now, this has all been auto-produced using generative AI. I've not had any input here. This is literally just what the system has produced. And this has basically created a model for me where we open an Uber app, we click the login button, we select a pickup location, we select the destination, we select the car type. Do they have a promotion code? We confirm the ride, we wait for the driver, and either we end up getting a car and that ends up being completed, or, the drive didn't arrive, there was something wrong with what we specified and the ride was cancelled. Now, this is by no means a perfect model. There's obviously lots of routes down here which are missing, like the car types, different promotion codes, different destinations, et cetera, et cetera. But to me, this is a fantastic starting point to starting to think about the kind of model we want to produce for our automation. And then obviously we can overlay this with the different testing artifacts, and eventually, very quickly we can end up with something that's going to be something that we can execute and automate against and create our automation scripts for. So we're doing a lot of work in this generative AI space. This is literally just scratching the surface of things that we're trying out at the moment. But I think the premise here, and to Marcus's point, the things that are going on in AI at the moment are pretty much changing the game. Literally, we're seeing new algorithms, new approaches come out every day. We're putting a lot of time and energy into this effort. And if you're interested, we'd love for you to follow along the journey. So if you follow us on LinkedIn, you follow us on any social media, you'll see lots and lots of videos coming out and new things that are going on there. I think the other core piece, which is an area which we're looking into, and also I think it's just a gap in the industry of where we are at the moment, is traceability. I think traceability is really, it's so often overlooked. If you think about everything that's flowing around the software development lifecycle, we have so much data. We have code, we have data, we have requirements, we have different integrations, we have different compliance standards, we have different users coming in and using the application, and we may have post-production data of how users are using that application as well. I think having traceability between all these components is actually absolutely key. If we're going to make more intelligent decisions over where we should be testing, what we should be testing, then actually we need to be collecting and harvesting lots and lots more data about how our applications are consumed and how we're building them, okay? If a developer has just made a change to a piece of code, which they have no experience in changing, that's probably an area of the application we want to be testing more extensively. Coming back to Marcus's standpoint earlier about, where he worked with that organization and he was using his own intellect and his own insight to make decisions over where users are using the application from his experience and areas of the application which are potentially important to the business, and he was focusing his testing strategy on them. We need lots more data around that so that we can start to automate those decisions and provide insightful information to stakeholders so that we can provide and enhance quality in the organizations we're working with. So I guess this is more of a kind of call to action. It's certainly something that we at Curiosity are looking into. I know the guys at Source Labs are making movements in this space as well, but I think traceability is really something that we need to start focusing on, especially as these intelligent algorithms start to become more prevalent. Yes, you could have the most intelligent generative AI algorithm in the world, or most intelligent large language model, but if you have rubbish and poor data feeding into that, you're not going to get good insights out of the outputs that it's reasoning from and it's generating its approaches from. So this is definitely an area that we need to focus on and move forward with kind of as an industry. So I've got a slide here just to kind of wrap up the conversation, but I guess Marcus, is there anything else you want to touch on just before I move on to this one?
Not at the moment. We have a really great question in the chat, which I'm looking forward to getting your take on once I talk about it. He or she actually requested to skip the question, but I actually do want to talk about it.
Thanks, Marcus. Not going to get an easy time today.
That's right.
Right. So if you're interested in carrying on the conversation, I believe these slides will be sent out. You can book a meeting with Curiosity. There'll be a link. I also highly recommend you sign up for a free trial of Source Labs. It's really easy to get going. Super simple to spin up a device, and there's lots of amazing tutorials. If you visit our website, either the Curiosity website or the Test Modeler website, you can sign up for a free trial. Similarly, we have quick start tutorials for getting started with mobile automation in Test Modeler, and there's tutorials which follow on from that on how you can connect that up with your Source Labs environment as well. So those are a good introductory series to get started, not just with model-based testing, but how you can combine model-based testing with Test Modeler and the execution in Source Labs, which I think is kind of the perfect combination, especially if you start to ramp up your testing and you need a cloud execution provider to execute those tests at scale. And then you'll just see down here, we've got some social media you can follow us guys on. But anyway, over to you, Marcus. Let's hit the questions, I guess.
Cool. Yeah, we've got a couple of really good questions. I would like to encourage some more. Hey, Heather, see you in a few minutes. Cool. So we got about 6-7 minutes for Q&A, and I would like to encourage some more questions to come in. First of all, I want to ask a real simple question. Can the models in the Curiosity, are they versioned like code, the models themselves with Git, or do you have to just help me understand?
Yeah, it's a great question. We've kind of gone through this battle quite a few times internally, because there's been this whole movement of everything is code. Certainly infrastructure as code is a big thing, and quite rightly so. I think the challenge with modeling is if you just put it in Git by itself, you end up with this structure, right? It has to be some kind of structure, either a JSON or an XML
Yeah.
or some kind of YAML configuration, whatever that is. The trouble there is that if you look at a model, it's a flow chart, and there's inherent structure between the nodes and the different connections which are in there, which actually doesn't play very well with a source control management system like Git, which has been specifically geared towards merging code and merging particular file types, right? So I think the particular challenge there with models and flowcharts is they don't version very well in traditional source control management systems. So what we've done is we've spent a lot of time building versioning into the product. So we have the ability to go in, you can fork, you can create new versions, you can put commit messages in. We haven't quite honed down on the whole merging piece yet. That's still something that we're going to go after. But I think the net of it is that models don't make sense in source control because it's very hard to manage them. You actually need a specific source control management system, which is built specifically for models. And that's what we've built on top of the whole modeling kind of infrastructure that we have. Hopefully that makes sense. And that gives a little bit of insight into why we've kind of gone down that direction. But I think everything else belongs in Git. Like, don't get me wrong. You've got an automation framework. We push automation code into Git. That's where it belongs. You look at your infrastructure, that belongs in Git. You look at a lot of the stuff you guys at Source Labs are doing with your YAML configuration files, 100% that should be in Git. I just think that for models, it's a particular challenge because of the structure that's kind of overlaid on top of it, I guess.
That's something I hadn't really considered. Like, I'm trying to imagine tweaking a model at the same time someone else has tweaked a model, and then what a nightmare the rebase concept becomes when you have this forking and branching. That's crazy. I can sort of see getting the hash of a version of a model and referencing that throughout, maybe
Absolutely.
in something like Git, but that's mind blown at the concept of that. Yeah,
Absolutely. Yeah, I mean, we've pulled hairs over this for so long.
I'm certain.
So,
I mean, you said you're going after merging, and going after merging seems to me almost more complicated than going after generative AI.
Yeah, potentially. I mean, honestly, the stuff the stuff we're seeing out there with generative AI at the moment is amazing. Like, for me to be able to literally go from text to creating a model, I was so overwhelmed when I saw that. I couldn't believe that. Firstly, a large language model could take some text and turn it into a JSON, but then also it can actually create the nodes and it can create all the edges between them and actually understand the logic and make connections. That's so amazing. I think honestly, it's really going to disrupt our industry 100%. And I think as we see it get more integrated into the tools, the approaches, the methodologies we have, and it becomes, the barrier to entry becomes much, much lower. That's where we're really going to see it come into fruition, right? But it's amazing, just the early stuff out there. It's fantastic.
Yeah, I know Nikolai is about to moderate the next session, and he's a huge proponent of it, and I think he would agree. What I find amazing is just the potential to do things like, so it feels like everyone out there is working on generating test cases using generative AI, which sort of all makes sense. What we're trying to approach, and I'm not like announcing a product feature here, is I want to be able to have a conversation, an intellectual conversation in a session with a log file that says there's 4 million lines of logs here. I want to understand, like, from a holistic point of view, what were the different stack traces? Where else have you seen these stack traces? How can I correlate those stack traces to something else? Was there an error in the API? And just be able to have a conversation to understand your log file without having to pour through and parse every element of it. That to me feels like a good angle for an APM or Sauce Labs to take on that kind of thing.
Yeah, I agree. It's kind of interesting because I'm just going to start a little video here because we're trying to do something not similar. Like, we're not in the log space at all, but we're trying to look at an angle of how you can chat to your models. Because for us, obviously, we're storing a lot of information here about how a particular part of the application works, right, and particular requirements for that application. So we started to experiment with large language models as a way to do that. So here, what I've basically got is some user stories in Jira. And then as we go through, we've kind of scanned those tickets and we've moved them into, our repository, which is fine. And what that means is I can basically go through and I can start to query that repository of everything that we have. So here I've said, what is Jira ticket CB13? Hopefully this is large enough. And what it's come back with is an explanation of this is what this Jira ticket is. But then we can start to build it a little bit more up. So this is talking about the functionality for a credit card. So we can ask a little bit more of an advanced question. When can a customer apply for a credit card? And here what it's done is it's taken a flow chart we've created for a credit card application. It's taken a user story and it's come back with all the steps that it's used to come to its reason, and it's reasoned over the sources that it's referencing. And here it said, therefore, a customer can apply for a credit card when they are 18 years or above, providing their personal details and financial information meet the necessary credit score and requirements given, right? And then we thought, well, let's try and see if we can connect lots of different data sources together. So here we're saying, what products can I apply for if I have good credit? And this has basically looked at lots of different user stories and has said, if you have good credit, you can apply for a credit card. You can also apply for a premium account. So I think this ability to go in and kind of query your requirements and query, essentially that last slide, right? All the different data sources you have, that's the missing piece, right? And that can solve technical debt. It can mean you're not reliant on specific stakeholders. And I honestly think what you're talking about there, if you've got logs in there, that would be amazing, right? Like the power of that is unbelievable. So yeah, I'll be very excited to see how that progresses. Cool. That would be fantastic.
Well, we got to wrap up and go to TestRail. There's one more question I want to answer real quick. May I know if Test Modeler includes a lot of simulators like different iPhones, Android devices? And the answer is, if you connect it to Sauce Labs, it basically has anything you want.
Absolutely.
All of them and at scale.